So today we continue with module 3, and module 3 is going to go with practical 1, and we are going to be talking about background of machine learning and some basic terms you need to know. So in the course outline, I've color-coded some of the topics. I would like to explain what it means. So basically, when we have module 3, practical 1, in the same color code, it means that the both of them is going together. So when we are handling module 3, we are going to also be handling practical 1. We also have module 1, we have module 2, mathematics, and so on and so forth. So let's go ahead to start, and then we explain some of these terms and theoretical concepts, and then we go ahead into the practical to set up the applications we need. So what are we going to cover? We are going to be looking at what actually is machine learning. In module 1, we discussed about artificial intelligence generally. Today we are going to be looking at machine learning. We're also going to be looking at application of machine learning in problem solving, conventional analysis versus machine learning, example of the handwritten digit recognition, explanation of terms, and a number of times there, and also we talk about pre-processing and feature extraction, and then we go to the practical, which is to set up the applications we need. So what is machine learning? The goal is to create models that could perform actions that is normally performed by humans. For instance, to be able to recognize spoken instruction, understand handwritten text, recognize possible danger, drive a car, recognize someone's face in a photograph, predict population of a country, or some other population parameter in some future time, and so on and so forth. So these are basically things that are normally done by humans, and then it's going to be done by machine. How do we create a model that is going to perform these actions? That is what machine learning is all about. So we talked about the 3 fundamental theories of machine learning. So we have the 3 of them. I'll just present it here. We have probability theory, which is actually the branch of mathematics concerned with analysis of random phenomena. So this is one key branch of machine learning and data science. So it means that you need to review probability theory and be able to solve some of the probability theory problems for you to proceed in machine learning or data science. So we have that a key concept in pattern recognition is that of uncertainty. This is because both noise through measurement arises as well as through the finite size of data sets. So what it means is we are not able to gather all the data from the population. We simply take a finite sample, meaning that kind of is not enough. So that creates some uncertainty. We are not sure of what the whole population is all about. So probability theory provides a consistent framework for quantification and manipulation of uncertainty and forms one of the central foundations for pattern recognition. When combined with decision theory, it allows us to make optimal decisions given all the information available to us, even though this information may be incomplete or ambiguous. So this allows the model or the system to make decisions given available information. So this is about the probability theory. The next one is the decision theory. And this is a mathematical study of strategies for optimal decision making between options involving different risks or expectations of gain or loss depending on the outcome. So what are we talking about here? We are saying that if we have several options, we have different probabilities of different possible things that you can choose from. You can decide to choose several options. So decision theory is going to help you to choose an optimal option. So let's look at a little bit of the theory. We have, assuming we have a set of input vectors x and corresponding target vector t of target variables, the goal is to predict t given x. For regression problems, t will comprise of continuous variables, whereas for classification problems, t will represent class labels. The joint probability P of x and t provides a complete summary of the uncertainty associated with these variables. So if we determine the joint probability of X and T from a set of training data that is called inference. Then decision theory tells us how to make optimal decisions given appropriate probabilities. Okay, so give me a second. Let me just check. I've been receiving this. Okay, sorry for this interruption. Let me just tell the person to stop. All right, so decision theory goes with probability theory, and finally we have the next one, which is information theory, which is a mathematical study of coding of information. So how do we code information using sequence of symbols, and how to transmit such information? So one thing I would like to let you know is that when you're talking about probability theory, we're talking about a mathematical study. Probability theory is mathematical study, decision theory is a mathematical study. So the three fundamental theories of machine learning and data science, they are all mathematical study. So that gives us a reminder, or makes it clear to us, that machine learning and data science requires some knowledge of mathematics. So it's not something really that you can just do without having some basic or background knowledge of mathematics. So let's move on to the next slide. Now, let's now compare conventional analysis versus machine learning, because before now we're able to solve a problem using some statistical analysis procedures. We're able to analyze data, get our result, take decisions. Why then do we want to switch over to machine learning? What makes machine learning a better option than the normal, traditional or conventional analytical techniques that we normally use using the principles or classical principles of statistics? First, to understand the edge machine learning has over the conventional statistics, we need to see how the conventional computing works and then compare it to machine learning. If you look at this figure, you see that we have a typical computer system analyzes data by taking input, and it takes in the program. The computer processes this information and gives you an output. So when you grab some tabular data into an application, maybe some SPSS or Excel, and then you run some analysis and you get some result. This is traditional programming, and although it's working, there are many issues with this problem, with this kind of this way of solving the problem. The problem is when you have a different set of data, it means that you need to either use another analytical techniques, or you kind of use a different application. So a particular application cannot handle all types of data, all different types of data, and a particular technique can also not handle all forms of data. For instance, you have a data that is made up of categorical variable and you have continuous variables. So you need to use different techniques to be able to handle this, right? So that means that as time goes on, we always need a human to be able to feed this input to select the particular technique or analysis to perform and stuff like that. So if you are having a self-driving car, how does it now manipulate itself or adjust itself based on various kind of data sets that is coming in? So let's now see how machine learning handles exactly the same problem. In case of machine learning, we need to provide inputs and outputs, and then the model will be, the result will be the program. So in this way, we have a machine is writing its own program. So once the data set changes, the machine is going to write its program to be able to handle this data set. So that means at some future time, you will not need any human intervention. So the machine learning system will always adapt itself. If it gathers new data, it will adjust its own program to be able to handle this new data. So that is the advantage of machine learning, and that is the key difference between machine learning and conventional computer programming. Now let's take an example of how machine learning actually works. We have handwritten digits, for instance 0, 1, 2, 3, 4 to 9. These handwritten digits, we want the model to be able to examine these digits and tell us what it is. Using our normal human eye, it appears very simple, but for a computer, it is not that easy. The first thing we want to do is to determine what is our input and output. In this case, our input is a handwritten digit, for instance, a 0. A 0 written in a handwriting is considered to be an image. And what is an image? An image is simply a set of pixels. In this case, we can assume that this is a set of 28 by 28 pixels enclosed in a box, just like we have here in this presentation. So we have a set of pixels. So if you actually enlarge it, it's going to give you the set of pixels. So I'm actually going to, okay, I can't adjust this at this point. So at this, just behind me here, you can see once we start enlarging these images, you can see that you have square pixels right there. So it means that the input is going to be a set of pixels enclosed in a square array of 28 by 28, and the output is going to be a single digit between 1 and 10. So how do we proceed to be able to recognize digits? So how do we proceed? That is the question. You have set of handwritten digits and you have some input output you are expecting. Based on the example, we need to provide the input and the output. So what to do, or what you need to do, is to first provide an input, which is going to be a set of vectors, which is 28 by 28 pixel of images. Each of these images represents a number. The output is going to be a model that can take in a vector and give us a number, right? And the output will be the actual number that is going to predict. For instance, it could see 0 and call it to be an O, or it could also call it predicted to be a 0. So let's now do a little more clarification. For this task to be done, we have to provide a series of handwritten digits, and this is called the training set. Each of these handwritten digits will also provide the actual number it corresponds to. So we are providing the input and the output. When we do this, we are training the model. We are showing the model the digits, and we're also providing it the outputs that it corresponds to. So this set of several handwritten digits that we provide to the model is called the training set. So for you to build a machine learning model, you need to have a large data set called the training set. The training set can be split into two parts: the training set and also the target vector. So the training set seems to be correspond to the set of independent variables, and the target vector corresponds to the output that is expected. So basically, if you have x1, x2, and you have y to be a function of x1, x2, we don't know this function. We only know that we have series of x1 and x2, and we have series of y values that correspond to this x1 and x2. So we need to provide all this data set to the system, and that is what happens when we perform training. When the machine or system looks at each of these input and the target, it will learn what relates the input vectors of the training set to the target. So it continues to learn. The more data you provide for the training, the more efficient the model is going to be, because it's going to keep learning or keep training. All right, so we also have the concept of pre-processing or feature extraction. For most applications, the original vector need to be pre-processed to transform them into some new space or variable where it is hoped the pattern recognition problem will be easier. In the case of the handwriting digit we mentioned, we enclose it in a box of 28 by 28. So it means that all the input is going to fit into a 28 by 28 box. So in this way, we can say we pre-process the data. So there is no input that is going to be beyond this particular size. When we actually do the practical problems, solve the practical problems, this is going to become a bit clearer. So for instance, in hand digit recognition, the images of the digit are typically translated and scaled so that each digit is contained within a box of a fixed size. That is pre-processing. And when this is done, the next step is going to be feature extraction. So each particular pixel in this 28 by 28 box represents a feature that has to be extracted. Some of these pixels may actually contain no feature or no information. So when the system examines each of these pixels in the 28 by 28 box is going to extract which ones are very relevant. If I have to go back in this slide and go a bit backwards, so you can see that in this case, you can see as some parts of this box, there are no information, meaning that the white part surrounding the zero contains no information, and just like the other parts. Where the information is contained is the part that is bright, is dark blue. That is where the information is contained. So the system needs to determine where the information is contained and extract this information, and that's the process of feature extraction. So at this point, we have some things we would like to clarify. The training set, we've mentioned the set of input and output set you need to provide for the model to learn or to train. The target vector is the corresponding target target variable, or the variable that is calculated from the set of dependent variables, from the set of independent variables. So this target vector is also called the the predicted variables. The predicted, or sometimes it's called the dependent. Then we have the test set. After building a model, you need to test it using some test data set. So that is why you need some small data set to be able to test your model, feed this data into the model and see how it produces output. And that's what data set you use to perform this test is called the test data set. We also have the validation sets. Validation set is also kind of the test set, but the validation set is extracted from the training set. So after training, you put in some training set into the model and see whether the output it gives you corresponds to the original output that was used for the training. Okay. So keep all this in mind, and then let's now see if we can set up a few things, because after now we are going to be doing the practicals. So the first thing you need to do, I'm going to put away this presentation at this point. So let me put away this presentation. All right, so the first thing we can do is to go to Google, and then we can download Anaconda and install this Anaconda in our system. So if you go to Google and you can just say Anaconda downloads, so you get to the download page at this point. So just go here and choose, if you are using Windows, you can just go to, I think it's still be in Windows, Windows, and download for Python 3.7. Once it downloads, simply install it. I've already installed it, so I'm actually going to stop this download from continuing. So again, if you are downloading, try to choose the graphical installer, which is this first option here, the graphical installer. Okay, so the next thing you want to do, if you are using Mac, for sure you download for Mac. If you are using Linux, download for Linux. The next thing you want to do is to set it up. So once you install it, just double click on the file downloaded. You are going to have Anaconda installed at this point. So you can see Anaconda Navigator, and you have Anaconda Prompt, Jupyter Notebook, and so on. I'm going to open Jupyter Notebook, and while it opens, we are going to go to Setup R. So when you open Jupyter Notebook for the first time, he's going to open this black screen, and after opening the black screen, he's going to open Internet Explorer, and it's going to open this page, right? So this is the home page for Jupyter Notebook for your local system or in your local workspace. So at this point, you've successfully set up Jupyter Notebook, and then go ahead to minimize this black screen. Don't close the black screen, because the black screen is like the server, and it has to keep running through the time, all through the time you are working with Jupyter Notebook. The next thing we want to download is RStudio. I'm going to also go to the browser and let's download RStudio. So let's go to google.com. Just say RStudio download. So there are a number of versions of RStudio. There is one that is free and there is one that is a paid version. So the free one is okay. We can use it for this lesson. So you can see RStudio Desktop, open source license, and it's free. So just go ahead to download. After you download it, just go ahead to install it. Meanwhile, you need to choose your operating system. Okay, so yeah, so there is a download. So click to download. So you have supported platforms. You can choose Windows 7, 64-bit, Windows 10. For me, I'm using Windows 10. So of course, Windows 7 Plus. So if you download this one, that'll be very fine. I've downloaded it, so I'm actually going to stop it from running. So having downloaded R, just double click on it and install it. And again, I'm going to open R side by side with Jupyter Notebook. If you go to your program files, you will look for R and just go ahead to open it. So go to RStudio, you can see right here, and then open it. Now you will also see, I'm going to show you another thing called idle Python. So if you scroll down, you'll see Python 3.7. So you can see idle Python right here. So idle Python is like an interpreter where you can write programs as well. So if I open idle Python, so it takes a while to open. Although I'll say you should not worry about idle Python. So let's not waste much time on it. I'm just trying to show you that there's something else out there that you can use. So this is Python interpreter or idle Python. So if you type something like 3 plus 4, you can see it interprets it and gives you the response. So if it's something you can use as a calculator to play around sometimes. Alright, so let's now talk about, first let's talk about RStudio. If you open RStudio, this is what you will have. At this point, you can just press Ctrl L on your keyboard and it clears off the screen. One thing I would like to show you in R is first I'd like to tell you about the console. The console is where you type something. So if I say 3 plus 2 or 23 whatever plus 5 and I press enter, it gives us the output immediately, just like Python, idle Python. Now if I want to save my work in a file, because now if you are typing and getting the result immediately, your result is not saved anywhere, meaning that you cannot use your code anymore. But if you want to save your result, you can create a new file. You can say file new and create a new R script. So at this point, let me clear the screen. Instead of typing in the console at this point, you can type here. So I can say 23 plus 5, exactly the same thing I type, and I can just click on run and it runs in the console. And while it's running in the console, I have it in this file called untitled. So to save this file, just say file and just go to save as and you give it any name. You can save it in any part of your system. You can call it R script, okay? So at this point we have our file saved as R script, so we can open it next time to continue from where we stopped. So if you don't use R script and you are typing in the terminal, then you are not going to have your work saved, okay? Alright, so another thing I'd like to show you is that you can get free data sets from R. Okay, so there are a collection of data sets I'd like to show you. If you go to packages, click on packages, and you go down to ISLR, If you go to ISLR, you can see lists of documentation for packages, package ISLR. So we have the auto data set, we have the caravan data set. So all these are sets of data sets that you can use for analysis, so you can use to play around, and you can use for learning. So one thing you can do, as I explained in module 1, you can export this data set to Excel and import it into Python. So we call it stealing data set from R. So you can steal data set from here and use in Python. I'm not going to go through how to export this data set to R, to Python, or to Excel, because that has been covered in module 1, exercise 1, module 1, close to the end of module 1. So basically, this is how R works. I'm going to close it this point, and let's go to Jupyter Notebook, because Jupyter Notebook is what we are going to be using mainly for this tutorial. So this is the Jupyter Notebook environment. I'm going to just increase the size of the screen a bit. So it gives you this workspace where you have some items in a folder. To create a new notebook, because Jupyter Notebook is actually where you write anything you want to write. Unlike other applications like spreadsheet or Arrow we just saw right now, Jupyter Notebook can contain both code, both text, both graphics, both program codes. Anything can be packaged into Jupyter Notebook as one single file. So for instance, to create a new notebook, you can just say new and just say Python 3. Here you create a new notebook. So in Jupyter Notebook, you have series of cells. You need to type in whatever you are working with inside a cell. Initially, the Jupyter Notebook provides only a single cell, which is here you can see is just one cell. But before we continue, let's just rename this notebook to, maybe we can call it, I think we are in module 3. All right. So to rename, just click on the name. Okay, there's module 3 existing, so let's call it module 3 practical 1. So you click on the name here and it gives you option to rename it. Okay, so now if you type in a command in Jupyter Notebook, you can either run it, or you can save it, or you can mark it down. To mark it down, it means you convert it to normal text that is not executable. Let's take, for instance, I want to do just normal y is equal to 2x. Let's first assign the value of x. X is equal to 20 and y is equal to 2 times x, right? So this is a simple equation, and now I can print out my result by saying print y. Okay, so this is a script. I've written a script now, and now I can just click on run. If I click on run, it's going to run this current cell. You know the current cell because it's enclosed in green. That is where your mouse cursor is. If I click outside, it becomes blue. I click inside, it enclosed in green, meaning that that's the current cell. If I run it, it's going to display the output here in a different kind of cell. So outside this cell, we have this cell called markdown cell. So if I click on this cell and go from code and click on markdown, it changes it to something, it marks it down, right? So, okay, so markdown, so it changes it to something else. So if I go back, I can change it back to code, but I think you might not have to worry much about this. So how do you save your notebook? That is what we already did. When you give it a name, you actually save it in the system. To find this notebook, you'll simply go back to home and just find it in the list of files in your system on your workspace. So this is how to work with R and how to work with Jupyter Notebook. Let me see if we are missing out something. So we have performing mathematical operations in Python and R. Okay, let me just show you one more thing before I go. So how do you create a list of items. You can create a list of items. For instance, you want to create series of items. You can say x is equal to 1 is equal to, so it's markdown, so I'm going to just convert it, change it to code. X is equal to 3, 4, 5. So now X is an array or a list of items, 3, 4, 5 items. So if I say at the end of the line, I say print X, is going to display X, as you can see. Actually, this is a one-dimensional matrix, a matrix of one row by 3 columns. I'm going to do the same in R so that we don't miss out anything. R I'm using because you might need to use it at some point. Some things are actually easier to do in R. So let's create exactly the same thing we created in R. In Jupyter Notebook, let's do the same in R. So I can just say X, sorry, I'm going to write here, X is equal to C, 3, 4, 5. I hope I get it, so I'm going to just run it. Okay, fine. So if I say X and just run it as well, it's going to display 3, 4, 5, right? So C stands for concatenate. So create a list of 3 items, 3, 4, 5, and this is also a matrix of 1 row, 3 columns. So I like to suggest you play around with Python and R. Try to write some mathematical equations. Try to solve it and see how it goes. Try to get used to the items, and also make sure you're able to get this data set, export them to Excel, and be able to import them into R into Python. And we are going to do this a little later. So I'm going to stop here, and the next lesson I'm going to just check the outline. We've covered model 1, we've also covered model 3, practical 1 we've covered, so we are moving into practical 2, installation and setup of PyCharm. So practical 2 is actually about programming, not machine learning and data science, because if you want to be good in machine learning and data science, you need some knowledge of programming. So practical 2 has to do with programming, and we are going to be using another application which is called PyCharm. I'd like to thank you very much for viewing. I'd like to recommend that if you have challenges, let me know and I'm going to respond to you. And we see you in the next class.